So today I am going to discuss on memory segmentation, very important topic in 8086. In 8086 we have 20 address lines and we can address 2 raised 20, that is 1 megabyte of memory. But this total 1 megabyte of memory we subdivided into different segments of 64 kilobyte. So here each segment is 64 kilobyte. So we have stack segment 64 kilobyte, and we have data segment 64 kilobyte, and we have code segment 64 kilobyte. And this is about memory. And we have in bus interface unit in 8086 we have segment registers. So here this is segmented memory and this is segment register. This is just 16-bit registers, 16-bit wide registers inside bus interface unit. So there is a connection between these two. Each segment memory, if you see code segment memory, each segment memory base address means starting address is stored in this 16-bit register. For example, see here, the code segment memory started at 20,000. Can we store this 20,000 in hexa into this register, code segment register? No, because this is 16-bit and this is 20-bit. See, this is 5 bits in hexa. 1 hexa is 4 bit. So 5 into 4, 20 bit. So 20 bit cannot be stored in this segment register. So here only first 4 digits, 1, 2, 3, 4. First 4 digits of segment memory starting address will be stored in the segment register. So code segment register hold the first 4 digit of code segment memory starting address. Now let's see. Then what about data segment memory? So this is data segment memory and it is starting at location 30,000H and its first 4 digits means 3000, and this 3000 will be stored in data segment register. It's very simple. Then let's fill it. Next is extra segment memory and it is 64 kilobyte. So what is the starting address? 50,000. So first 4 digit 1, 2, 3, 4. 1 0 is missing. So 5,000. So 5,000 should be stored into extra segment register. And these all are in hex, okay? So next, this is stack segment. Stack segment memory, and this is also 64K. 64K means its address can be from, for example, in 70,000 to 7FFFH. If you 00 set FFF, it is 64 kilobyte. So 64,000 locations. Sorry, not exactly 64,000. 64 into 64K is nothing but 64 into 1024. It is 64K is 64 into 1024. 1K is 1024 in this memory, in binary, not 1000. So okay, no need to deviate from the topic. Let's see. So here again the stack segment memory. So starting address of the stack memory, that is 70,000, and its first 4 digit is 7,000. So 7,000 will be stored in stack segment register. Okay, and let's see, each segment is pointed by some pointer registers. Code segment memory is pointed by instruction pointer. Data segment memory is pointed by mainly SI and DI register, source index register and destination index register. Extra segment memory is pointed by DI registers. DI register, basically this is used in DI is pointed extra segment memory in string operation actually. string operation. We will discuss in detail when we come the topic of string instructions. Then stack segment memory is pointed mainly by stack pointer, and it is pointing top of the stack. But base pointer also can point any location in the stack segment. So stack segment memory mainly pointed by stack pointer. So basically push and pop operation, when you use subroutines, that time the stack pointer will be updated when you do push and pop operations. But base pointer also can point any location in the stack memory. So here then any so all are the 16-bit, but the physical address is 20-bit. If you see, this is 20-bit. So how this 20-bit physical address is calculated? This 20-bit physical address is calculated by segment register into 10H plus offset. So offset will be stored in these point registers. So if it is using code segment, offset will be only in instruction pointer. If you are using data segment for calculation, it can be in SI, DA or BX, any registers. Indirect addressing, register indirect addressing, you can use the BX also. So this is the segmentation of memory. So segmentation is the process in which the main memory logically divided into 64 kilobyte segments, and each segment has its base address stored in the segment register. It is used for increase the speed of execution because each segments are divided, so there is no mixing of data and mixing of instruction, so it's very easy. So code segment memory stores the instructions and it is pointed by instruction pointer. So this is a memory segmentation. Let's see some example. Find physical address memory pointed by DA. So an instruction is given. I haven't gone through the instruction for you yet. So let's see, this is very simple. Move DA, AL. So AL data, 8-bit data should be moved to a location pointed by DA. Okay, so this location physical address should be calculated. So it will have an only logical address of 16-bit. So physical address is DS into, so as it is in data segment, DS into 10H plus DA. What is DS value is given? 0223H. So 0223 into 10H. Where is the equation? Yeah, into 10H. This is the equation, into 10H. So into 10H, instead of in multiplication, we can append a 0 on LSB side. So plus DA. What is DA value? 00CH. So 00CC. 0 plus C, C, 3 plus C, then 3 plus C, D, E, F. So F, 2 plus 0, 2, 2 plus 0, 2, 0. So this is the physical address. This is physical address and it is 20-bit. So this operation, who is doing this operation? In bus interface unit, this calculation with segment register value, IP, all this calculation, 20-bit address calculation is done by this address circuit. Programmer no need to know about this. What is the advantage? Let's see. Segmentation. So segmentation divides the memory logically to store instruction, data and stack operation in separate segments. We already discussed it. It permits programmer to access 1 megabyte of memory using 16-bit register. I hope you understand this point now, because we have instruction pointer only 16-bit, but we are accessing of 20-bit memory using segment registers and point registers. Segmentation allows for relocatability of code. So relocatability code is another advantage of segmentation, that is code can be reloaded to any location without malfunctioning, because code is not using absolute addressing. So it's not using absolute addressing. Here we are using a logical address, and we are calculating the microprocessor is calculating the physical address. So relocatability of the code is very easy. Whenever it is reloaded to another location, the logic works without any malfunction. So this is about segmentation of memory. Thank you.